In this video, I'm going to show you how to construct truth tables for compound propositional logic statements. In section 1.3 of the book, we have three building blocks or three basic operations in propositional logic, and we'll add to this before the chapter's over, but these are our three main types of connectives throughout propositional logic. And to remind you of the truth tables, these are the truth tables for these three things. So we have the logical AND operator, the logical OR operator, and the logical NOT operator. And so for each of these three operations, we know what the truth table should look like. So the question is, when we build a more complicated proposition, how do we go about using this information to build a truth table for the more complicated expression? The main thing is to make an analogy to arithmetic. We're going to work from inside the parentheses out the same way that we would evaluate an arithmetic expression. To make it clear, let me just show you an example of an arithmetic expression. If I had something like 5 times the quantity negative of the quantity 37 plus 14, it's pretty apparent if we try to do this, if we think we have to do this by hand, that I can't evaluate 5 times anything unless I know what this anything is. Similarly, I can't figure out what minus this thing is without first knowing what this thing is. And so if I were evaluating this, I would do things in this order. I would first work out what 37 plus 14 is, then I would negate it, and then I would do the multiplication. So that's the order, 1, 2, 3, the order in which I would do the operations if I were evaluating an arithmetic expression. Well, the same thing's going to happen with propositional logic. We're going to first build a truth column for P or Q with the logical OR, which we already know how to do. Then once we have that, we're going to build the truth table for not P or Q, and the not operator is easy to work with once we know what the logical values of the part inside is. And then finally, I'll do this logical AND operation. So just like with the arithmetic operation, I'm going to work 1, 2, 3 inside the parentheses out. So here it is written down step by step. We'll first create a column for P or Q, because that's the thing that's that's the thing that's inside the parentheses the furthest. I will use that to create a column for not P or Q with an extra parentheses there I see for no reason. And finally, we'll be able to create the truth, a column in the truth table for the whole thing. So here's what it looks like in the context of the truth. The thing on the right here is the expression that I'm trying to find the truth table for, and then I have added additional columns in the order that we just talked about. So you'll see there 1, 2, 3 is in the same order that I just was discussing. It's not, it's hard to get out in front of yourself on this, because what you're really doing here is you're figuring out stuff as you need to know it. In other words, I can't just do this because this is the AND operation between two things, and I don't even know what one of them is. So I know I need this truth column in order to be able to do this larger one. And so you can think of it as I'm putting this here, thinking I need to know that in order to get this answer. And then similarly, I can look at this and say, well, to get this answer, I need to know what the P or Q is. And so I put it there. So in a lot of ways, what you're doing here is you're sort of working your way back to the right, asking yourself, what do I need to know to build this? And then giving yourself additional columns for that information. And if you do it right, and there are often more than one way to do it, but if you do it right, you'll see that everything you're doing now is just based on those basic building blocks. So for example, column 1 here, it's just the OR operation. So P or Q, we know that P or Q is, it's only false in one position. So it's usually true and it's only false in one place. So we know that the only way that P or Q is false is if the P and Q variables are both false. And then otherwise, this is going to be true. You'll feel more comfortable doing these if you can sort of think along these lines, rather than on every problem have to really think through carefully what's happening in that row. So the OR operation, the F, the false, is sort of the more rare occurrence. It only happens when the two variables that are being used are false, and otherwise it's true. The not operation, in the second column, not is really just saying use the opposite truth value from what's inside the parentheses. So once we have the truth table for P or Q, as I do in column 1, then not P or Q is just literally flipping the truth values of those for that column. So again, I'm not really giving a lot of thought to a particular context or going row by row. I can really think of this almost as an evaluation of the propositional logic expression. And then finally, I have P and not P or Q. So the P column, let me mark it. The P column is over here, and the column for not P or Q is here. So this column is the AND operation applied to two columns that I already know. So now the only way that an AND operation can be true is if both parts are true. So I can look down these two columns, the two columns that make up my AND operation here, and just see, is there a row where I have true and true at the same time? And you can see here that I don't. There is no row where both the P column and this column are both true. If there were, I would put a T for that row in this next column. Since there aren't any, that tells me that this column is just all false. So when we're building these tables, especially when the propositions are fairly complicated, we can think of it in terms of these three things. When we have a negation, we're applied to something. This A could be something complicated. As long as I have a column for A, I can form the truth table for not A by simply reversing the truth values from that column. That's exactly what I did going from this column to this column. If I'm trying to form a conjunction, a logical AND operation, then I'm looking for rows where both of these two columns have a T in them. If the column for A and the column for B have trues, then the compound statement will be true, and otherwise I'm just going to put an F in every other row. In this problem, there were no rows where both the first part and the second part were true, and so I ended up with falses in all of them. But you'll remember that I didn't have to go row by row really thinking about it. I really just based it on the columns that I had previously created. And then finally, if I'm trying to form a logical OR, then I'm looking for any row where the column for A and the column for B are both false. That will make A or B false, and every other row will make A or B true. And that's exactly what I did here. So here's a problem for you to try. The compound statement is given there, and I've left space for the rows, the other columns that you'll need. So first, think about what additional columns, how would you put labels here so that you will be able to evaluate the truth tables for these columns and lead up to this one. So take a second and try that. I'll pause for 3 seconds. You might want to pause the video, and then I'll let the video go to the next slide that has the answer to that. So here are the headings that I used. I figured that I needed a not Q column. Once I had a not Q column, then I'd be able to do this, because this operation needs a P column and a not Q column, and I have those now. This operation needs a column for Q, which I already have, and needs a column for P and not Q, which I now have. So I should be able to do it based on that. So now try to actually fill in the truth values for this table. And again, the next slide will have the completed table on it. So if you want to try it yourself, pause the video and wait till you've actually completed your table. And so finally, this shows the completed truth table for this compound expression.